Yeah, so till now we have seen something called as classical ML. We're going to be working with the logistic regression and the linear regression and also a couple of the other algorithms. So what happened in the recent years, like 2012 onwards, deep learning is much more popular when compared to the classical ML, what we just now learned in the previous classes. So if you look on to why we are using deep learning, so the deep learning concepts were more popular after 2012. So why it is more popular and why we are learning deep learning, the concepts came into the picture. So firstly, I will introduce what exactly the deep learning inspired by, and also the how does the deep learning going to be helpful in terms of the classical ML, and where we are going to be applied, and also some of the different applications we had. So let's check out this diagram so that you will get some idea how does it's going to be inspired by the human neuroscience or human brain. So if you just look onto your brain, you have so many neurons to understand, and it also going to be manipulated with respect to whatever the dendrites and whatever the axon you have. So I hope you know some of the terminologies for the neuroscience. If you take this diagram, so this is something called as cell, right? So we can call it as cell, biological cell of the neuron. So the cell consists of something called as axon. So this axon we represented in terms of the deep learning mechanisms to inspire, and something called as a node for that matter. So we'll also discuss more in the deep learning stuff, but let's understand the domain knowledge and why we inspired by using this brain itself. So you can see some of the other dendrites we are going to be showcased with respect to the other connectivity with respect to the other node. So this is connections we're going to be made, and you can also see this axon. This axon is going to be helpful whenever you connecting with the other cell. This is a one cell, and this is the other cell. This is the other cells. So like that, we are just connecting with the so many cells. If you go and see the how many neurons inside your brain, you will get 100 billion. So you can it may not be countable even, so but as per the scientists, and they also made some of the analysis corresponding to the neurons, how does it going to be helpful and what is the count for that, maybe 100 billion plus. So you have 100 billion plus neurons. That's a reason whenever you see any object like this, if you suppose you're going to be see any kind of the object, the neurons going to be fired with respect to whatever the different cells you had. So if suppose it's going to be capture the objectiveness and also some of the regions of this cat, but some of the other neurons is going to be capture this is a cat, and the color having the cat is white, color having the you can say eyes and also the ears differently. So we are not sure about the which neuron is going to be fired us, but we just inspired by using these mechanisms or be these kind of the terminologies by using the brain and also the neuroscience, whatever they have learned in the medicine. So we just drawn this concept and try to applying into our deep learning mechanisms. So you can also see one of the other application we just inspired by this. If you take any picture of your brain, it's going to be give as the MRI scans like this. So this is going to be give somewhat in a sense to understand and also capture between the some of the images to classify whether you have a tumor disease or you have a, some of the Parkinson disease by using the new whatever the brain scans you had, MRI brain scans you had. So if you just pass into your brain scans according to whatever the nodes, or you can say whatever the hidden cells corresponding to the neural networks you had, then it's going to be produced as you have a tumor, you have a hemorrhage, or you have an infraction kind of the disease. So I would say this is the domain knowledge terminology, biological neural network going to be termed together. And this is somewhat in terms of the computer networks and also called as CNN terminology. So I will explain you and also the connecting dots with respect to the biological and also our deep learning mechanisms concepts. So let's go on to this. So corresponding to the each and every cells, we just now drawn whatever the input information you had from the cats, right? From the cat, you just seen your information you captured from your retina by using your eyes. Then it went to your neurons. The neurons is going to be captured and also it fired together. Whenever it's captured something, it's going to be fired to the other cells, right? So it fired to the other cells and it's also going to be captured. This is a cat. So like that, you're going to be connecting the dots or connecting the nodes with ear itself, right? Connecting the cells in the medicine language. So if you take any like any look kind of the neural network model, so this is, we can call it as cells, right? Cell state for the biological term. So for the deep learning concepts, we can call this as neural network. Neural network. Collection of the neurons, it consists of some of the nodes and also the input and hidden states. We can call it as a neural networks. So in the neural networks, we have three different states. One is the input node or input state. This is the input where you get all the MRI brand scale images. So these are all the input shapes, or you can say input nodes. So this is the hidden states or hidden nodes. We can also call it as hidden states or hidden nodes. And this is the output node. So we have three different. Okay, so let's go and check out the other diagram. Yeah, you can see here input layer or input state, hidden layer or hidden states, and output layer or output states. So these are the three different states we have that was inspired by biological neuroscience. So if you just consider any state, suppose if you consider this state and try to understand what exactly these nodes and what exactly this layer consists of. So these each and every data point, whatever we learn as independent data points in the classical ML, independent layers are independent data points. So we just passing through our xi at the time, xi and also the yi. So yi is a target variable we are going to be get as an output results in the end for a classification task. For a regression task, we are going to be predicted as a real value number, right? Similarly, in the exercise, we are going to be take consideration as an input for the neural networks, whatever the nodes we had. You can see x1 is a one data point, x2 is another data point, x3 is another data point. So like that, we are going to be get all different data points up to xn. How many data points you had? Suppose you have around 1000 comma 20. So you're going to be end up with the 1000 data points what you had along with some of the column results. So what will happen if you're just passing through your simple or single neural network? You can say this is a very simple or single neural network. The single neural network is going to be help us to understand and try to find some of the features to learn automatically. So that is a major advantage with respect to the deep learning. So the I can say this is the one of the major applications in terms of whatever we are currently using. If you say language translator, and if you say voice recognition systems, and something called as Alexa, and any such operations with respect to the NLP related and also the computer vision projects, you can say. So this is very popular after completion of 2012. So the 2012 is the world changing idea in terms of the deep learning mechanisms we are using. So before that, we don't have such mechanisms. So many scientists and mathematicians spend a lot of the time, around 50 years of the time, to construct these deep learning mechanisms. So yeah, that's also some of the history about the deep learning. So if you just understood about some deep learning mechanisms inspired by the neuroscience, that is very helpful. And try to understand what exactly this function does. So this is the function. We can also call it as activation function. So we already learned in the classical ML called a function which are going to be learned whenever you give some of the input results. Suppose this is a function. It try to understand some of the features or some of the updated weights and also construct some of the patterns according to whatever the independent variables you had. Similarly, in the deep learning, you can see this will going to be learn the features automatically. without any evidence or without any kind of the information you want to be give. But in the classical ML, you had to do so many things, right? Around to construct some of the hyperparameter tuning along with some of the, you can say,